Now let's explore the fundamental theorem of calculus part 1. Now recall that the fundamental theorem of calculus, the evaluation part of it, goes like this. If we want to evaluate a definite integral, we find the integrand's antiderivative. We plug in the top limit minus plug in the bottom limit, and that's how we evaluate a definite integral. So a is a constant and x is a variable here. Now let's suppose I want to differentiate this integral right here with respect to x. Well, that's the same as differentiating this side over here. So I'm differentiating f of x minus f of a. Now if we go ahead and do that, if I differentiate the first term, f of x, minus the differentiation of the second term, f of a, here's what I get. The derivative of f of a is just going to be 0 because f of a is a constant. It's a number. So this whole thing just yields f prime of x. In other words, notice we start off with f prime of t. When we differentiated this integral, we end with f prime of x. It's just like we just replaced the t with an x. See? Same function, f prime, f prime. Here's a t, here's an x. Now let's look at an example. Let's suppose we've got the derivative of this integral. The integral from 2 to x of this thing, the square root of t squared plus 7t. The way we evaluate it, this thing right here equals exactly this, the square root of t squared plus 7t, only we replace the t with an x. See? I just replace the x where the t is. Instead of t squared, I've got x squared. Instead of 7t, I've got 7x. And the principle involved is just like what we discovered over here. Because when I plugged in the 2, I got a constant. Well, the derivative of a constant is 0. Now let's look at another example. Here we've got sine t squared from negative 2 to x. Well, notice all I do is replace the t with an x. And there we have it. Now, let's look at this. Let's suppose that the variable is in the lower limit, and then in the upper limit there's a constant. Well, what we're going to find is that that's going to be just like the other, except there's going to be a negative in front. Let's see how that works. Here is back to the evaluation part of the fundamental theorem of calculus. I got my antiderivative. I plug in the top limit minus the bottom limit, like here. Now I want to differentiate. Well, now notice, here it is. I'm going to differentiate. So I've got the derivative with respect to x of f of b. Ooh, f of b is a number. So this derivative is just going to be 0. This is just a constant. Minus the derivative of the function f of x. Well, you've got a minus in front and you're taking the derivative, so you just get negative f prime of x. See, because this part is just going to be 0. Okay, let's look at an example. Okay, the integral from x to 2, we're taking the derivative of it. So all I do is I put in the 2 in place of the t for the t cubed and for the 7t, and I get this. But because the variable is in the lower limit, I put a negative out front. Likewise with this one, where we have sine of t squared, I'm going from x to negative 2. There's going to be a negative in front because it's the lower limit that has the variable. Okay, now let's suppose that we've got some other function up here, not just an x. We've got maybe x squared or 4x or something like that. We're going from a to some function of x. Well, that is going to be f of, I still plug in like usual, only I've got to multiply by the derivative of b. See? So I'm just going to plug in b of x, and then I multiply by the derivative of b of x. Let's see how that works. Once again, we have the evaluation part of the fundamental theorem. Here it is. Now let's differentiate both sides. Okay, I'm differentiate this side. Now dig this. I'm differentiating this right here. Well, this is going to involve the chain rule, right? I'm going to have the derivative of the outside times the derivative of the inside, and this over here is just 0. So notice the chain rule is afoot here, right? F prime of b of x times b prime of x. This is the chain rule. I've got to multiply by the derivative of what's inside. So look at an example here. Here we're going from 2 to 4x, the derivative of this. So what I'm going to do is I'm going to put the 4x in place of t. See? Instead of t squared, it's 4x. Instead of t cubed, it's 4x cubed. Instead of 7t, it's 7 times 4x. But then, notice the extra part. I multiply by the derivative of this bound right here. The derivative of 4x is 4. Now, I do the same thing for this other example. I'm going from negative 2 to 4x. I plug in the 4x in place of the t, and then multiply by the derivative of 4x. Now let's look at what happens if we have a function of x in the lower limit and the upper limit. So here we've got this derivative of this integral, and what we're going to find is it's going to equal f of b of x, the upper limit, times the derivative of b of x, minus f of a of x times the derivative of a of x. Okay, so this looks complicated. Let's see how this works. So here is the evaluation part of the fundamental theorem, right? So we just plug in, we get the antiderivative, plug in the top limit minus the bottom limit. Now, let's take the derivative, because what we're doing is we're differentiating this integral. Well, if we differentiate, here's what we got, right? Let's continue on. So we've got the derivative of f of b of x minus the derivative of f of a of x. Now, the chain rule is at work here. So we're going to take the derivative of the outside times the derivative of the inside. F prime of b of x times b prime of x. That's what's going to be this. Minus f prime of a of x times a prime of x. So it's going to be like this, right? See? Because I'm just differentiating, just using the chain rule. Now let's look at an example down here. Okay, here we've got this thing, and we're going from x squared to 4x. So first, I'm going to take the 4x and plug it in place of t. There it is. Instead of t cubed, it's 4x cubed. Instead of 7t, it's 7 times 4x. And then I multiply by the derivative of this top limit right here. See? Okay, that one's finished. Minus, now I'm going to plug in the x squared. Okay, I plug in the x squared in place of t. See? And then I plug in the x squared in place of t here. And then I multiply this term by the derivative of x squared, which is 2x. And there you have it.